Okay, so the first problem is to show that these 3 points are collinear, which means they're all on the same line. Now there's a couple ways to go about it, but I think probably the easiest way is if I just pick any 2 points and find the gradient, and then pick a different pair, or well, one of those same points with the other point, and check the gradient of those two. The gradient's the same, then since they have a point in common, they must all be on the same line. They can't be on parallel lines because the 2 different pairs I would have checked would have shared a point. So it doesn't matter which ones you pick, remembering that the gradient is y2 minus y1 over x2 minus x1. So don't forget the y always goes on top. So I'll just pick the first 2 points. So it's going to be minus 5 minus 7 over 1 minus 2, which works out to be 2/3. So now that was the first pair. That was that pair and that pair I used that time. So this time, I'm just going to use this pair and this pair. So I'm going to compare the gradient from those two now. And I already did those two, and they have a point in common. So obviously if they have the same gradient, then they can't be on 2 parallel lines because they share a common point. So I have minus 1 minus 5 over 7 minus 1, which works out to be 4 over 6, which is the same as 2/3. So 2 different pairs from these 3 points have the same gradient. They share a common point, therefore they must be on the same line. Now the other way to do it, which a lot of you did it, was use one pair of points to find the gradient and then find the equation of the line using y equals mx plus c. You put 2/3 in there for m, and then you use one of those points to find c, and once you had the equation of a line, you then use your other point, your third point that you didn't use for the gradient, to check to see that it lied along that line, and you would find that work. So either way would work fine for this problem. Alright, question 2 was to write the equations of 2 lines that are perpendicular to each other. So this was very open-ended, and I wanted to see what level of understanding, and this ties in closely to question number 3. So if we remember, if lines are perpendicular, then their gradients are negative inverse. So you could have picked anything you wanted. So I'm surprised more people didn't just pick something very easy and basic like y equals x and y equals minus x. Those 2 lines are perpendicular. One of them has a gradient of 1, one has a gradient of negative 1. What about y equals 2x and y equals minus 1/2 x? Now those are perpendicular also, and as you'll see when we go on to question 3, that if you had used a choice like one of these 2 that I did when there was no y-intercept, it's going to make your work so much easier. Or if you pick something like y equals 2x plus 1 and y equals negative 1/2 x plus 1, that would have made doing question 3 that much easier also. Now, I notice some people pick things like this, y equals 3x plus 7 and y equals negative 1/3 x minus 3. Well, yes, that works. Those lines are perpendicular. But of course, when we get to question 3, we'll see that if you had done a question something like these 2, your work in question 3 would have been much harder. Whereas if you pick something like this or like this, where the y-intercept is the same, it would have made doing question 3 much, much easier. Okay, question 3 was to find where the 2 lines that you used for question 2, where they meet. Well, as I pointed out in question 2, if you picked a pair of lines like I did here, which are perpendicular, they both have a y-intercept of 0. So where do these lines intercept? Well, they intercept at 0, 0. I know the top point goes through the point 0, 0. That's its y-intercept. I know the bottom equation goes through this one here, goes through the point 0, 0, because the y-intercept is 0. So they both go through 0, 0. Now, if you pick something like this, 2x plus 1 and y equals minus 1/2 x plus 1, the same thing. If I look at this first one, the y-intercept is 0, 1. If I look at the second one, the y-intercept is 0, 1. Therefore, where do they intersect? They intersect at 0, 1. Now, those of you that did something like this, y equals 3x plus 1 and y equals negative 1/3 x minus 4, Well, in order to do that, you need to do simultaneous equations, which many of you did, and you came up with the right answer. However, you took up a lot more time and a lot more work than you needed to by solving simultaneous equations. So once again, as I stressed in class, you have to have a really deep understanding of these topics, really understand what it means to be the y-intercepts, for lines to be perpendicular. So that if you have that deep understanding, these type of questions are really, really easy and you can do them very quickly. Okay, question 4 was to find the distance between point A and the midpoint of AB. Now what many of you did was you found the distance between A and B, which is not what the question was. So there's two things you needed to do here. First thing you needed to do was find the midpoint of A and B. So the way to find the midpoint is we add the x's, -3 plus 3 over 2. That's going to give me my midpoint x-coordinate, and add the y's, 2 plus -4 over 2, and that's going to give me my y-coordinate midpoint, which works out to be 0 and -1. So this is the midpoint. Now the second part of the problem asks for the distance between A, which is -3, 2, and the midpoint, which is 0, -1. So we can simply use our midpoint or distance formula. And again, you don't even really need to know the distance formula because you just realize we use Pythagoras to find the distance between 2 points. So we need to find it's going to be the square root of the sum. So we want to find how far apart are the x's. How far apart are the x's? Well, I can just simply do, let me slide this back up. I can simply do -3 minus 0. That's the distance between the x's squared, plus the distance between the y's is 2 minus -1, and that's squared. So I have the square root of 3 squared plus 3 squared, which is the square root of 18. Now again, we should always simplify our surds. We know the square root of 18 is the same as the square root of 2 times the square root of 9. So this simplifies to 3 root 2. So this is the distance between A and the midpoint. Not as many of you did find the distance between A and B. We need to read the question very carefully. Okay, let's look at question 5 here. Again, we have two temples. One is 40 meters. They're both on opposite sides of the river. And from the top of the 40-meter temple, I look down on the other temple. So obviously the other temple is going to be less than 40 meters, and I need to find the height of the temple and the distance across the river. So let's do the river first. So the question is asking from the top of the 40-meter temple, I'm looking at the base of the temple on the other side of the river. So obviously here's my right angle, and I have a right angle triangle. I know one side of my triangle is 40 meters. So of course I need to know an angle or another side, and I can use trigonometry to find the length of the river. Well, there is some other information they give me. They give me that the angle of depression from the top of the 40-meter tall temple to the foot of the other temple is 21 degrees. So the angle of depression is 21 degrees. So now I have two different right triangles I can use. Either one is fine. I can use this one here, in which case I know one side is 40, I have a right angle, I just need to find what that angle there is. And so that's the way I'm going to do this one here. Well, if the angle of depression is 21 degrees, then this angle here must be 69 degrees. So, and I'm trying to find the length of the river there, x. So we need to determine first what ratio we're going to use. Well, if I'm dealing with this angle here, then this side is the opposite side, and this side is the adjacent side. So which ratio uses opposite and adjacent tangent? So it's the tangent of 69 equals opposite, the opposite side, which is x, divided by the adjacent side, which is 40. And x is the river. So the river is simply going to be 10 times 10 of 69. So the river is simply going to be 104.2 meters. Now the question didn't specify, so since the units were given in meters, you could go to one decimal place or you could round it to the nearest meter, 104 meters. Either answer for this problem would have been acceptable. Okay, for the next part of the problem, we're trying to find the height of the temple. So this time, what I'm looking to do is I'm on top of the other temple and I'm looking at the top of the temple across the river. Now I know it's going to be shorter because if I'm standing at the top of the 40 meter one, there's an angle of depression, so I must be looking down on the top of the other temple. And they give me that my angle of depression looking down to the top of the other temple is 12 degrees. So once again, we're looking for a right angle triangle. So we can find it. If I just draw a line in here, you can see we have a right angle triangle there. Or if I draw my line up this way, I have a right angle triangle up there. And we can use either of those right angle triangles. If I use this one up here in pink, well, I know one side is 104.2. I know that angle is 12 degrees. And if I can find this side, x, that won't give me the height of the temple, but if I take x away from 40, that would give me the height of the temple. So the question now becomes, I have a right angle triangle, I have this angle here that's 12 degrees, that's x, and of course the length, which is here, 104.2, is this same length up here. So it becomes, which ratio are we going to use? Well, I'm dealing with this angle here, so once again I'm using the adjacent side and I'm using the opposite side. So if I set up my ratio, I'm going to use tangent again. So tangent of 12 equals the opposite side, which is x, over this side, which is 104.2, over 104.2. So I'm going to solve for x. So x is going to be 104.2 times tan of 12, and I think x works out to be roughly 22.149 and on. So remember, that's not the height of the shorter temple, that's the height of this bit here. So to find the height of the shorter temple, the whole length from the top of my horizontal line here to the bottom is 40, and x is 22.19. So to find the height of the temple, I'm simply going to do 40 minus 22.149, and then I'm going to round that. And if I rounded it to 2 decimal places, it works out to be 17.85 meters is how high the shorter temple is. And of course, the problem didn't specify, so we could go to 17.9 or perhaps even to 18. So I hope this clears up all the problems that you may have had on this quiz. Again, this is all background knowledge that we should be very well prepared for the exam.